Ladies and gents, welcome to TFI. This is a long overdue, much requested video, all to do with 2D sketch constraints. I've got a spare half hour. I thought, right, let's do it. Let's get it out the way and done. For all the newcomers to Inventor who need to understand these sketch constraints a little bit better, because I remember what it was like to look at them and go, what the hell are these things? I have no idea what any of them mean. So we're going to start by doing 2D sketch. We're going to drop the 2D sketch onto one of these origin planes. These are your starting planes for new 2D sketches. Think of them as bits of paper. So I'm going to select the XY plane, and that gives us a sketch plane, a bit of paper, if you will, placed onto that origin plane, where we can now start drawing lines, arcs, circles, rectangles, and the like. And then you've got this cluster of buttons up here. These are your 2D sketch constraints. And now I remember looking at them, and I remember what you're thinking right now is you need to be part of some secret club to understand what they all mean. I mean, like, what's that thing there? It looks like a shoestring. No idea what it means. So I'm going to take you through what all of them are, what they do, each of them, when you'd use them, and what they're for. But to help understand why you need them in the first place, what we're going to do is jump over to AutoCAD and look at how things used to be done back in the olden days before AutoCAD even had 2D constraints, which it does. And we'll look at traditional drafting. So in AutoCAD, what you would do back in the day is you would say draw a rectangle. And let's make it a square, 100 by 100. And then we'll put a circle, I don't know, at the midpoint of the top. And we'll make that 20. And then we'll do another circle at the midpoint of the bottom line and make that 20. And then we'll trim all that out there. Okay, so that gives us a very basic kind of plate design. Maybe it's like a metal plate with two flaps, top and bottom. If you go on a proper Autodesk training course at a reseller or something like that, you'll hear the expression overused, design intent, right? You capture the design intent. We're all about capturing the design intent. Whilst the expression makes me cringe somewhat, there is some merit to it. In that if your design intent, if you intend for this design to be a certain way, you put in constraints to force the objects to respect your design intent. For example, these two semicircle objects here, this one here and then this one here, if you intend for them to always be on a center line, well, back in the olden days of AutoCAD, you couldn't do that. The objects were completely independent of each other. So if there was a change in the future and this object needed to be moved maybe 50 mil across to the left or 20 mil across to the right, then this one here just stays put. But the design intent is that this one here should always be on a center line with that one. So you'd use a constraint to force them onto a center line, and then when you move one, the other moves with it. That's the whole point of 2D constraints. Similarly, that line here stops here. You see there's now a break between the top edge of the rectangle or the square and then the end point of the arc. Well, you can place a 2D constraint in Inventor to always keep that point there touching that point there. So that'll never cause a break when you move objects around. So back in the olden days, we just didn't have constraints, but nowadays we do. Nowadays we do. Ooh, I like that. I do like that new AutoCAD selecting window. That's nice. Right, back over to Inventor. So with Inventor, we can use 2D constraints to plug in this intelligence into our sketches to stop things from falling apart. You can get away with doing sketches without creating 2D constraints, but it's going to be messy, it's going to be dodgy, flaky, and in the future things are just going to fall apart and you're going to have a bad time. Luckily though, Inventor does help you out by giving you constraints as you're sketching. For example, if we draw a line from just one random point to another, and if you just move your cursor down so it's roughly horizontal, can you see it's snapping there? It's snapping to the horizontal. And if you look above the little tooltip that says 0.00 degrees, there's a little square icon there with a horizontal symbol. I know it does look like an upside down Loch Ness monster fin, but it's actually a horizontal constraint being automatically applied to the line. So when you click this point here, Inventor is forcing horizontal constraint onto that line. Therefore, this line will always be horizontal. So when I click the line, you can see the glyph there. That's letting you know that that line is forced horizontal by a horizontal 2D constraint. So if I grab the endpoint of this line and move it around, I can put the mouse in circles, it will never, ever, no matter what happens in the life of this line, it will never, ever be anything other than horizontal. And that's the whole point of 2D constraints. That's the whole point of them. Right, so we'll do something similar to what we had in the AutoCAD sketch. So let's look at the front of this sketch. So we're looking straight down onto it, hit the front face of the view cube, and we'll do a rectangle. Let's start with a rectangle. 100 tab 100, and then we've now got a whole bunch of constraints already in here, and we've done nothing. We've done absolutely nothing. The first constraints that it's applied are little yellow, you can see these little yellow squares at the end point of the line. Those are called coincident constraints. A coincident constraint tells Inventor that two endpoints are always going to be touching each other. And not necessarily always endpoints either. You can make a line coincidentally constrained to another line, and it just means that object will always be touching that object. So for example, let's draw another line here, like that. And if I want that endpoint to always be touching this line, don't know where, not in the midpoint, not in the endpoint, I just wanted to always touch that line. Well, then you'd go up to your sketch constraints and you'd find the coincident constraint. So go do that. It's up there. Just coincident. Exactly. You're looking at the sketch palette and you're going, I don't know which one the coincident constraint is because they're not labeled. So what I find is, for a newcomer, the best way to interact with constraints from day one, just whilst you're learning, is to right click, go to create a constraint, and then you get them all here, but they're named. So you can get a little word next to all the icons and it'll tell you what they are, as opposed to just having to guess what they are from the top palette. So if you right click, go to create a constraint and then select coincident, select the endpoint of the line, click that, and then click this line here, and then that'll create the little yellow square, and now the two objects are always going to be touching each other. You can now no longer pull this line off of that square. It's always going to be touching it. Even if it's upwards, it's still coincident to that. It's still in line. Doesn't have to be actually on it, but it can still be in line with it. So that's the coincident constraint. Inventor will automatically create it at square corner points. If you do other rectangles, slots as well, for example. So if we do a center to center slot, there's coincident constraints created where the arc meets the straight horizontal line on the slot. Those are automatically created for you. Again, for a slot, here we go. We've got some tangent constraints automatically placed at the 4 points around the slot. Inventor knows that you're creating a slot, therefore this arc here should always be tangential to the top and bottom horizontal lines. So you can get away with not manually creating them, but there are times where you do need to manually create them. So back over to the AutoCAD example. Another constraint that we've got here are these two here. Now you might not look at them and think of them as being constraints, but they are actually constraints. They're called numerical constraints, aka parameters, aka dimensions, but it's still a constraint. You are numerically constraining that line to be 100 millimeters long. That's what it means. You don't see this on the drawing, this one here. You don't see that on a drawing. You don't see it on a print. It's a numerical constraint. You are numerically telling Inventor to always, no matter what happens throughout the rest of this model's life, always keep that line at 100 mil. And it will be. You can drag it around. It's now forced to 100 mil. If you select that dimension, hit delete on the keyboard, that line is now free to be any length it wants. But as soon as you say create a dimension on here and then make it 100 mil long, it's numerically forcing that object to be that length. So it's still a constraint, it's just presented in a different way. Okay, so some other constraints that we've got. We'll do the AutoCAD example. So we'll draw a circle, and then what we'll do is we'll snap to the midpoint of the top edge, and that creates a constraint. That creates a coincidental constraint at the center point of the top edge of the rectangle. See the little object, the little glyph goes green. That's to let you know that there is a snap at the top edge. So just like AutoCAD, you can right click. It works in a little bit of a different way, but you can go point snap and then midpoint, and it'll let you snap to the midpoint of that line, which is nice. That's nice. It just saves you having to manually search for the midpoint yourself. And we'll type in, well, actually it was a radius of 20, so we'll do a diameter of 40, and you can see the little yellow squares created, so it's coincidentally constrained to the top edge of that square. So now as we move it around, that circle is always placed at that point. No matter what happens, we can move this around with the left mouse button, and it's staying put. It ain't going anywhere. So yeah, it's that's kind of the whole point of them. And we'll do it again at the bottom. Circle, right click, point snaps, midpoint there, and then we'll do 40. Okay, let's do a bit of trimming as well, just like we did in AutoCAD. So we'll hit trim, 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 and trim. Just be aware, if you do any sketch modification commands such as trim, extend, scale, any of those, it can break the objects and break the constraints. It's forcing you to remove entities from within the sketch, which can therefore remove where constraints have been applied to. So if you've constrained something to a line and you trim that line away, though, that constraint is going to break because that line's no longer there. So trimming objects can cause some things to break, and as you can see, it's done just that. We've broken this top edge and this bottom edge into two halves. So this edge is now no longer one straight horizontal line. It's now been broken up. So this is where you would additionally create 2D constraints manually. Not applying those 2D constraints manually would be devastating to the sketch. It just wouldn't work. So we need to now add in some 2D constraints to make sure that we capture the intent of this design. And that's where the rest of these constraints come in. So what we'll do is we'll start with making sure that these two arcs are in line with each other, because at the moment they're not. You can see these two arcs can move side by side to each other, completely independently to each other. So you've got to think to yourself, well, what kind of constraint do I want here? Now, there's no such thing as a centerline constraint, but what you can do is think, well, these two objects here are needing to be vertically aligned with each other. I want that point to be directly vertically in line with that point there. So we can right click, create a constraint, and then we can go to vertical. Right, so what you then do is you click the center point of the circle, click the other center point of the circle, and then that will vertically align those two objects together. Hit escape, and now these two semicircles are always going to be vertically aligned with each other. There's still a bit of work to do though, so we need to try and figure out how to get these two lines here and these two lines here to stop being completely higgledy-piggledy and wonky. So what you can do there is there's never any one right way of doing it. There's multiple different ways of doing this, but you could think to yourself, well, these two lines should be horizontal to each other. So you could right click, create a constraint, horizontal, click these two lines here, and then you'll see it gives you an error and it says, whoa, hang on a minute, you've just asked me to make the line horizontal. You've just clicked the line. You're asking me to make the line horizontal. It's already horizontal. The problem's not that the line isn't horizontal, it's that it's not horizontally aligned with this one. So you go, right, well then there's another way of doing this. You can say make the end point of that line horizontally aligned with the end point of that line. And then that brings them in line with each other. Now, I'm going to press Ctrl and Z here and undo that because there's a different constraint for this type of scenario. You can right click, go to create a constraint, and you can select something called collinear. Collinear places two lines onto the same axis and they don't necessarily have to be horizontal or vertical. So if you select collinear, you can pick that line there and then that line there, and then that will put them on the same axis. And what I mean by they don't have to be horizontal or vertical is if I draw a separate line here and then say a separate line here, and then we go right click, create a constraint. I need to press escape, so out the line command, create a constraint, collinear. Where has he gone? Where's he gone? That one there. Make these two lines collinear. They're now on the same axis as each other. So that's what collinear is. It's actually a really good one. That is a really good one to know. Doesn't always apply just to horizontal and vertical. It can be any angle, but two lines will then be on the same trajectory, if you like. Okay, right, so what else do we need to do here? Well, looking at the design, you'd think, right, okay, what other kinds of design intent do I have in this sketch? Well, I know that this edge here and this edge here need to be the same length. And I also need to apply the collinear constraint at the bottom as well, not forgetting that. So we're going to go collinear and then these two lines here. So I think this line here and this line here need to be the same size. They need to be equal to each other. So you can select the equal constraint, pick these two objects here, and then that makes those two lines equal. And because there's a whole bunch of constraints down here, almost mimicking what's going on up here, then this line here and then this line here are now not really by default, but as a result, they become equal themselves. And then from that point onwards, you might find you get to a point where you've got no more room for 2D constraints. You've placed as many 2D constraints as you need to. The only thing left now is to place some dimensions on to get the sizes right. That might be what's left to do. But in this case, there's not. There's a few more that we can place. So for example, the arc, you can see it's completely it's constrained. It's in the right place, but it's free to move around. It's not really the center point of the arc isn't in the right place. So what we can do is we can say, right, I need this arc to just be a perfect, nice tangent arc coming out from the profile of whatever plate this would be. So I want this center point here to be in line with this top edge. So we can right click, we can go to create a constraint, horizontal. I want this center point to be horizontally aligned to there. Same at the bottom. I want this point here to be horizontally aligned with there. And it forces the object to be horizontally aligned to that other object, and it will be indefinitely. Okay, the shape's pretty much done now. The best way to check that your shape is done is to hold the left mouse button down on any point and then just drag it around. If your object doesn't break and fall to pieces, then you're pretty good. couple of other things to do is to place the objects central onto the sketch. So you don't want, this is just a best practice thing, you don't have to do this, but it's just a best practice thing. Don't leave your sketch just floating somewhere up here. You see this little yellow dot here? That is the center of the model. Think of your bedroom, think of your front room, think of the absolute central point between all the walls and the floor and the ceiling. That is the dead center of your living room or bedroom. That yellow point there is dead center of the 3D model, in model space, if you like. So we want this to be symmetrically placed around that center point, around about there. So it's symmetrical that way and it's symmetrical that way. So how do we do that? How do we get it to be symmetrically aligned to the center of the model? Well, it's pretty simple. You just use 2D constraints again. You want the center point of this line here to be in line with the center point of the model. So you go back to your constraints, create a constraint, horizontal, and you can pick the little midpoint there and select the center of the model. Right click again, create another constraint, vertical between the center of the model and then the central arc. Notice the lines have got a different color as well. When your lines are green, that means they can move in some way, shape or form. They have a degree of freedom within them, whether it be to change size or change position. Whenever they're green, they can still move. When the line goes purple or blue, based on what color scheme you're using, of course. If you change Inventor's default color scheme, you might have different colors here. But when your lines change color, usually to a darker color, that means they are fully constrained. And you can check down here at the bottom, and Inventor is saying things are fully constrained. There is no movement anywhere in any of the objects. Everything is fully tied down. So we've covered quite a few of the 2D sketch constraints there, but there's a few other ones which we haven't touched on yet. So what we've looked at so far, we've looked at coincident, we've looked at collinear, we've looked at equal, horizontal and vertical. So there's a couple of others. One being perpendicular. So perpendicular is when you want a line to be perpendicular to another line. So for example, we can draw maybe we're going to do an extra bit on the outside of this plate. So we can draw a line coming out from here. And if you want this line to come out at a 90-degree angle from this line, well then you'd make it perpendicular. So you'd right click, you go to create constraint, perpendicular, that between that. Now you might be thinking to yourself, well, why didn't you just make that horizontal? Well, because this line here might not be vertical. This line here might be at 45 degrees and you still want that line to be perpendicular to it. So that's when you would use the perpendicular constraint. So for example, line, another line, right click, create a constraint, perpendicular between here and here. Therefore, if this line suddenly changes angle, this line here is always perpendicular to it. So sometimes there's right and wrong ways of doing something. Again, it's all about you using your brain to decide, right, that line needs to always be a certain way in relation to another line or another object. And that one is perpendicular. Right, what else have we got? We've got parallel. Okay, parallel is when you want two lines to be parallel to each other. So we might have a couple of objects here. Let's say, for example, we've got, trying to think, well no, we'll just use the example of two lines to keep it simple. So we've got two lines running alongside each other and we want them to always be at the same angle, the exact same angle as each other, running parallel alongside each other. So you'd right click, create a constraint, and you'd say make that and that parallel to each other. You get the little parallel glyph there, and then when you move or change the angle of any of those lines, they will always remain parallel to each other. So it's totally different to making two lines horizontal or two lines vertical. It's forcing two lines to be parallel to each other. Now, you would very rarely do that with just two lines. You would typically tend to have maybe, I don't know, some kind of shape. So it would have a profile, which is something like this, and you might have a chamfered edge on one side of it, and you're creating a feature inside that plate which needs to be in line with the chamfered edge. So you might be drawing another feature over here somewhere, and that needs to be in line with the edge of a 3D model, the edge of a sheet metal cut, anything like that. It could be anything, but it's always when you want something to be parallel with something else, click the two lines and they will always now be parallel. Okay, so that's a parallel constraint. What else we got? We've got a couple more to cover. We've got tangent. Tangent's a pretty straightforward one. So let's draw a line straight down, and then what we'll do is we'll create an arc from here, this endpoint. So our arc is going to extend around there, and then we're going to draw a line coming out from the arc, maybe up there. Right, so the tangent constraint forces an arc and a line to be perfectly tangential to each other. So it's almost like the arc becomes a circle and its quadrant point is intersecting the end point of the line. It just comes out at a perfect circle from the end point of the line. So what you do is you right click, you'd select create a constraint, tangent, pick the arc, pick the line, and that now makes that a perfect circle coming straight out of that line. So that point there would otherwise be the quadrant point of that circle. It would be the left hand side quadrant point of that circle. Same goes for down here. We can go to right click, create a constraint, tangent, select this line and then this line here, and that's now given us a perfect tangent. Now you can automate tangential constraints though. You don't have to do those manually. You can automate them. So for example, draw an arc, select the end point of the line, pick the second point of the arc, and as you move the cursor down, you can see it's going to snap where it would be tangential to that line. So it's pretty easy to do automatic tangential constraints. All right, what else we got? We've got concentric. Right, concentric allows you to place a circle or an arc concentrically positioned to another one based on center points, really. So we could do a circle like this. That's a bit big, maybe that big. Right click, create a constraint, concentric, place that circle and then that arc, and it will place them onto the same center point. So this circle is now sharing the same center point as that arc because they are concentric to each other. So that's concentric constraint. What else we got? We've looked at collinear, we've looked at equal, we've looked at horizontal, vertical. Fix is a bit of a cheat, but it's sometimes useful. A fixed constraint is, for example, when you're doing something like I don't know, maybe a construction line. So you draw a line, you'd select it, make it a construction line. Now that construction line is able to be moved around, and you don't really want to concern yourself with having to place dimensions and 2D constraints on a construction line. So what you can do is just say, right, create a constraint, and then I want to fix it. Select fix, pick that line, it just goes blue. It's just now fixed. It can't move. It can change size because it's not a numerical constraint, but in terms of its position, it's fixed. It cannot move anywhere. And you can do that actually for any object really. So there's a square, right click, create a constraint, fix, and then select any of the lines here. And rather than having to do horizontals and verticals, if you're happy that the object is as it should be right now, it is in the right position right now, you can just fix it. But when you do that, you are completely limiting what you can do with that in the future. I mean, you can delete the constraints. You can select the line, select the padlock, press delete, and that will remove the constraint. It's a cheat, but it can be helpful for some scenarios. Back to create constraint, the final one we've got is a symmetry constraint. So the symmetry constraint is what it is. It makes two objects symmetrical around a center line. So for example, we can do, let's do a rectangle here, and then we'll do a, I don't know, maybe we're going to have like a chamfered edge. Let's just track along, and then like that. And then we'll do another section over here, track along like this. And I need this line here and then this line here to be symmetrical. I want them to be on the same angle, whereas right now they're not. See, that line there is free to change angle. So what we can do is create a center line running through the middle of here. So we'll draw a line, create it as a construction line. It can be a construction line or a center line, it's not important. But we'll draw a construction line in, right click, create a constraint, symmetry. And then what you do is you pick the two objects that you want to be symmetrical, and then you pick their center line, and it will create that symmetrical constraint. Those two lines are now symmetrical around that center line. And that's, again, useful for a whole bunch of things. Not limited to just that scenario. There's all kinds of different scenarios you can use these constraints for. They are indeed applicable to anything that you can sketch. So I am showing some very limited examples here. But that's the symmetry constraint. Some of the things which you might find useful. Let's just get rid of this sketch. Some of the things that you might find useful is the ability to create a sketch without Inventor automatically applying constraints as you're sketching. So for example, when I select line and then move it to the horizontal, it's probably best if we look side on so we actually are getting a horizontal line. You can see it's going to be automatically creating a horizontal constraint. Now if you hold down the control key on the keyboard and keep that held down, you can now free sketch without Inventor automatically placing constraints. So if you do need to create some kind of bizarre shape and you don't want it to start snapping to the horizontal, you can do that, and Inventor will not create any constraints at all as you're sketching. So that's one thing that's nice to know about. So let's delete that, and then let's wrap this up. Let's wrap this up by looking at how to show and hide constraints. This button here on the sketch panel bar is called Show Constraints, and what you can do is just select any line and it will show and display the constraints. When you press escape, it'll keep those glyphs enabled on that object so you can visibly see what constraints are being applied against that line, because quite often you'll lose track of what constraints you've applied and what's been automatically applied, and you need to keep a track of that by visibly seeing the glyphs, so you can then say, right, well actually I didn't want those two lines to be parallel with each other, so let's get rid of that line. And that will now allow us to be a bit more flexible with how we create the sketch. So that's select that button there, which is Show Constraints, and then pick the object. You can also use keyboard shortcuts of F9, which turns everything off, and then F8, which just turns everything on, all constraints. It's F9 and F8. There is more to sketch constraints than that. There is a whole bunch of options in here which lets you configure how constraint inference and relax mode works and various different ways, but we'll not go into that in a very basic beginner's tutorial, so we'll leave it there. That's 2D constraints at a very basic introductory level. Hopefully that is enough to get somebody going with 2D constraints in Autodesk Inventor. So if you did like that, do hit like on the video if you want to stick around, hit subscribe for notifications and stuff on future videos, and I'll see you in the next one. Toodles.